Hello, this is the first video that we are going to implement the ReadUntil web server that we already implemented in Zig. We are going to do it in Rust. So what I did was I moved all the Zig implementation into the Zig folder. It's the thing we reached, and that we created in the streams, in the recordings, and we are going to implement the same thing, but this time in Rust. So I just initiated a Rust project, but this is just, simple Rust project, and nothing is inside, so we can start. Okay, let's start. So let's start by looking into the cargo TOML file, right? So package is Rust version 0.10 edition of 2021. Okay, so first of all, I'm gonna change the name of this project to ReadUntil. This is our web server. The version is this, and the edition is this. Okay, so Rust offers, if I want to do a short introduction to Rust, I'm going to say that Rust is probably in the same space as Zig and C++ and C, in the space of performance, system level, having no runtime or minimum runtime code, and zero cost abstractions and these kind of stuff. Rust is at least in my experience, I have written some Rust before, and it's a much more complex language than Zig, but it offers some really great static analysis for us, so we can basically make sure that our program is correct at the compile time. The compile time, the type system and the ownership system ensures that our programs are correct and we cannot face any error at the runtime. Also, the documentation and things like these, and also the libraries and the ecosystem is much more mature and in reach, because it's an older technology and it has reached a level of maturity, and it's been using in a lot of big corporations and enterprises like AWS and Amazon. Okay, so Rust, I think it was when they did add Rust async stuff, I don't know. I don't know, but when they added async keyword into the language, I don't know. But anyway, Rust has async keyword built in. Okay, it's available to use in a stable Rust from version 1.39. I think the latest version of Rust now, I just installed Rust. I think it's, do we have cargo version? Yes, cargo version. Also, there is Rust C, I think, for -v, dash version. Yes, 1.60. There's also this Rust up command for toolchain. I can do show, yes, Rust up show, and it will give me all the implementation, all the information about my installation of the Rust, and we see that I have the Rust compiler 1.60. So async is here for some time, is in Rust, but it's like the implementations of other languages, so it has the coloring problem. Zig solves that, but of course, writing the Rust async code is a bit simpler than what we saw in Zig. But actually, let's start implementing, and we can compare bits and pieces when implementing this. So Rust has this concept of runtimes, basically the same concept of event loop in the Zig, and there's a standard runtime for Rust async, and also there are community built based on what purpose you want that async runtime. So the most popular one is Tokyo, called Tokyo, and we are going to use Tokyo. So let's start. So we use Tokyo to to have an async TCP listener, a runtime for writing reliable network application without compromising speed. Okay, so how we can add Tokyo? We should add it to our cargo.toml file. This is how we add Rust libraries. And you see that just now this is actually far simpler than adding a library in Zig. It is not a fair comparison because Zig is not version 1 is not stable, the standard library is not stable, and there is no official package manager. Rust has been in is I think in first stable version is, okay, I did it wrong, okay, Rust 0.1, sorry, Rust 1, Rust programming language. First stable version had appeared, no, I want the first version. Can I find the first version? History? Sorry. It says the same year work shifted from the initial compiler to an LLVM based self-hosted compiler written in Rust C. It successfully compiled itself in 2011. So Rust first stable release on 2015. So the stable release were in 2015, and they had 6 years of, time for doing stuff. Zig still has not reached their first version, stable version, so it's not fair to compare them. So we added, and so each Rust package has a name, a version, and of course a list of features, because most of the times you don't want all the features that a package is going to give you. You probably want a subset of those. Can we see how, what are the, okay, yes, here, the feature flags. We can see, but this is how actually you can make your probably compiled binary smaller and probably faster compile time. So full enables every feature. Maybe we just need net, but since but let's just use full. Maybe we can do some nicer stuff with other features as well. So okay, so we have this. I should do a cargo download, cargo build. I should let it download everything. If it takes a while, I'm gonna pause the video, but I hope that Rust is a bit famous for the compile time. It's like C++ in that matter, but okay, that was fast. Okay, cool. So let's start. You know what? For simplicity, I'm gonna do. I'm gonna write this as a binary, but then I'm gonna extract the binary part and put it into the examples folder like we did in the Zig implementation. So we need fn main in here, and main function is not found. Consider the main function. Okay. Should we add this pop? And can we do print line? Hello world? So basically a Rust library and Rust binary, they're just different in the main file. The main file of a program is main file of a library is lib.rs. And that is it. Can we run this? Let me close this tab. So let's go into, okay, let me check actually the font size. I think it's cool. Cargo run. Yes, we got the hello world, which is cool. So we can move on. So what we should do for Tokyo net, which is the sub namespace we should use. There's this TCP listener we are going to use. So the TCP listener is a struct. We have examples. So we need to do use. We need to create a TCP listener, a loop. Okay. You know what? Let's just copy this. Yes. Okay, this is one of the things that is starting to, you know, you can see the difference between Rust and Zig in here. So in Zig, so let me actually do a comparison. I think one up, go into Zig. Oh, I went. Okay, I went in Zig. Examples, there's source main. So you see that there's no basically async keyword in here. You see, we don't have any async keyword in here. Basically, async Zig code looks completely like sync async code. Sync Zig code. This is not true for Rust, because Rust, you see async keyword all over the place. Functions are annotated by async, and also our main, because main functions cannot be async by default. For Tokyo, for example, you should annotate it using this syntax with basically saying this is your main function Tokyo, and Tokyo is probably going to wrap it in some way so it can then run it as the main function. So what this code is going to do is creating a listener on port 8080 and then doing await. So await. So let's take a look at what Rust, how is async working in Rust. So bind creates is an async function, takes a generic parameter called a of type A, returns an IO result of TCP listener, where a, the generic parameter, it can be converted into a socket address. So basically this syntax in Rust means it implements this trait. Traits are like interfaces in Rust. Rust is has much more features than Zig. So, and strings probably implement that. Actually, let's take a look. Maybe we can use our IDE. Maybe we cannot. Where is that thing? We cannot go into there. Okay, back, and back. Await basically means unwrap it. Same await in most of the languages. Okay. One other thing, every async function basically wraps its output, any type it is, for example this type is iResult, wraps it inside a future. I don't know if we can take a look at futures or not. Future. Yes. So future is a trait basically for asynchronous computations, and it has some it has this poll method. What these are internal async stuff. If you want to know more about these stuff, there's actually a nice video that can tell you what in here. I will share. I will put this link down in the. This is a really good channel if you want to know about Rust. There is this there's this cross stuff, Rust, I think. Yes, here, async await. Basically explaining what async await, how async await works in Rust. And also there is another one which is really nice, which implements async await feature in Rust. This is a really long video, but it's a really good one. So sorry. So basically every async function returns a future, and futures can be awaited with .await method, and question mark is just like try in Zik. So let's move on. So we have a listener now for us, and we are going to accept a connection. This is going to be async, and then we have this process socket function. So listener.accept returns an IO result of a tuple of socket address and TCP string. We don't need the socket address, of course. We are going just to get the stream of data, and we pass it into the process. This is basically our handle function, right? Handle. Let's just call this handle in here as well, and remove this. Use of undeclared IO. Okay, I need use std IO. It says I'm not using this, so we are going to use it. Okay, sorry for the disruption. Yes, so what I'm going to do, let's actually explore this a bit. So okay, my handle is also an async function. Okay, so I'm gonna await on the result in here. Actually no, I'm not gonna await. Why should I await? Oh no, we should await, because in Rust, until you await something, it won't get executed. We can actually test this out. This is nice. So let's just do socket dot, probably there should be a write method into why we have this socket TCP stream. That was this TCP stream. So a stream has write method. So why it's generic? I don't need this to be generic. So I got one. I'm actually going to do is Tokyo net TCP stream. So it's socket dot write buffer. What is B? Writable, try write, is write all, attempts to write an entire buffer into this write. Yes, I want, okay. Write all. So it gets a self, it's not important. All this funny business in here because of the type system. Mute is for mutable, normal, but this is, it's basically saying this is a reference to itself, and the self is, for now, is the TCP stream, we know that, but this code A means the lifetime A. So this write all has this lifetime parameter, and basically we are saying that, okay, if you don't know, for example, how much source is going to live, it's going to live same as self, and also the outputs going to live as same as the input. Okay, let's continue. I had a long disruption. Where were we? So okay, so we were going to try to write on the socket, see how that's gonna work. So you see the write all basically returns a write all in okay. Is it async? Yes, it's an async function. So we can do await consider adding a semicolon in here. Write all gets a buffer. Hello world from Rust. Cannot borrow socket as immutable. Unused result must. So let's see. So it's basically saying that, okay, after this await, we are returning, and I should do this. You either should return a result of something, or what kind of error you return. Let's say error. Tokyo net. Why my Rust analyzer does not TCP error? So, oh, this is a syntax error because this is a Rust. Okay, so so it basically returns a write all. Will continuously returns a result of nothing. This function returns error that await. So let's just do IO result of unit, if I can type, and can we do return? Try wrapping this expression in an OK. Why we need all of these? Let's take a look at what we have as the sample. TCP stream, await, OK. So let's just wrap. Actually, not wrap this. Let's just create the OK. Okay, cool. So we have this await. Okay, so this is not an error. So actually, let's run this. So cargo run. It's running on port 8080 as always. So let's connect to this on port 8080. We get the hello world. This is nice. So how we can test this is async. We can test our famous async way of doing these. So I want to check something. What if I remove this dot await? I want to show you that it's probably not gonna work. If I run this will not work, because I told you that every feature of Rust, basically every async function, until it's not awaited, it's not going to be called, basically. So we need this dot await in here. And also I actually think that dot await is actually a more smarter move than having await as a keyword, because you can chain basically things with dot. But if you have await as a keyword, you cannot chain things. So this is, I think, better syntax, better way of doing. It's the same thing. But we can just see the coloring problem. So basically our handle function is async, only can be called in an async context to be async. My main should also be async because I want to call an async function, so I need to. So basically a whole part of my program should become async because I want to call an async function. So this is a problem with this implementation of async, but I mean, I'm gonna say that this is actually easier to understand than the async of Zig. Everything is so explicit. in Zeek, you for example, in Zeek, if you remember, let me actually open our source code. If you remember, we had lots of problems when we were working in here. You remember that we had a lot of problem with finding out the frame size and everything, and we basically were randomly doing stuff that were making it impossible for the Zeek compiler to find the frame size at the compile time. But this is a more explicit syntax, less magic, but it has the problem of coloring. So we have the async. What should we do next? So we are going to do a implementation of HTTP request. So let's create HTTP. So in Rust, I think we can create a struct. In Rust, types are not values as Zeek. They're not like Zeek. You're basically part of language itself. So struct request has method, and method is itself enum. Can we have a enum inside a request, inside a struct? I don't know. Expected. Okay, we cannot do this. Okay, so we have get, post, put, patch, option, and delete. Okay, and the method is going to be method. Yes. So we need method, we need a URI, which is going to be a string. Okay, so is this going to be, so Rust has two types of strings. One is a string and one is str. Basically a reference to str. So string is a struct, basically like vectors in Rust. Basically list of characters with known size at runtime. Pointer to str is just a reference to a string. Okay, since it's data, so when writing Rust code, we need to think in terms of ownership. So who's the owner of this data? Method, of course, it's owned by request. String URI is also owned by request, so it should have the value in here. We shouldn't have any reference to anything. The value should be owned by this type. So we also have headers version. Okay, so we have version, and we have an enum for version as well. If we can type, so that's HTTP 1.1. Can't we do this? No. And also HTTP 2. Of course, we don't support HTTP 2, so it has only one variant, but okay. So we got version. Next would be query params, path params, and reader, and headers. So headers. So we need to import the hash map implementation from a standard library. So this is one of the problems with Rust Analyzer. std hash map. Why you don't give me use std hash map? Okay, where is Rust hash map? Why it's not working like should? Rust hash map. hash map std collections. It's a type in std collections hash map. Let's just use this. I don't know why it's not working like it should. Okay, so headers is hash map of key value and s. What is s? Random state. Oh, it's for the seed of the hashing algorithm, I think. So it has a key and it has a value. Okay. So the key type of our headers is going to be string. Value is also string. Okay. So we got query params, which is also a hash map of string to string. We have path params of hash map, which is also string to string. So I think that is the whole request, and we also have the reader. So we have the reader, which is a TCP std io TCP string, probably in a stateful. It's probably in a stateful thing. So not Tokyo. Nope. Tokyo net. And we need a comma in here, which is nice. Let me answer this. Okay. Request. Okay. So we should create this request. So let's take a look at our algorithm. We have these. Okay, init. We read the first line. Yes. Until the delimiter \n \r. \r/n, basically the character return and the line feed. So we read from until there. But I think that Rust has simpler ways to do this. Simpler way to read a stream of data line by line. So let's implement a method on request. Implement request. If I'm right, I have not been writing Rust for a long time. So how was this called? Init? Rust. There is this Rust conventions, I think. There was this document. Yes, naming. API guidelines. There's this thing that we can for general control. Oh, with new. Okay. So we should say new returns a request passing a reader, which is a Tokyo net TCP stream, and we need this arrow, which is really I don't see why they needed this. I really don't know. And of course it can fail, so we should return a result of this, and we should have an error type. Yes. So the error type is going to be request async error. This is an enum. Actually, enum request async. Okay, I actually don't know what should they do now. Rust result error. Let's see, std result, recoverable error. Okay, result is a generic type. Okay, and error, and the error type. Oh, okay, I get it now. Okay, I get it now. So I can say type of, so Rust has type aliases, so I can say type request parse or HTTP parse. I'd like the request one better. Request parse is std result of request and error is just string. std, where is that? std result. So it's std result. I think we can ignore this, right? Yes. So I can return a request parse result. So what it is saying is, let me fix this. Okay, what it is saying is, okay, it says your function returns nothing. So we should start a reader dot read line. Is there a thing or lines? Split, try. There are a lot of stuff. Split. Okay. Readable. Okay. I have much disruptions this night. Oh, okay. Read returns, pulls some byte into a buffer. I remember that the Rust has some nice stuff for reading. Let's see. So there is this. Can we write this, for example, line by line or something into... Oh. Maybe this is cool, because maybe this will give us some nice methods on TCP stream. Is there trait implementations from into read? So when you implement read, you implement so many things. Okay. I need to give some answers to messages. It says take create service read. Okay, so no, it seems like that we don't have anything useful. Oh, we have the into and from. Oh, these are actually nice traits. The type system is really nice in Rust. I have a video on how these works. These blanket implementations work basically. Into std, how we can read stuff. Here, do you have any readable? Try IO. Into split. No. Into std. What will this give us when I'm reading? I want, yes, so read, there is this read takes a buffer, there is this read to end, read to string, read exact. I don't want this, of course. ReadBuff exact. What is exact? Okay, byref bytes take. Okay, so there is no read until. Okay, there's no read until. Let's see. Let's actually search for this one because it's a bit not nice too. So Rust Tokyo TCP ReadUntil. Something like this. ReadUntil. Let's see the Stack Overflow. Okay, it says IO ReadUntil. if you have something that implements read, you can use the buff reader type to turn it into a buff read. So if I give you a TCP stream, you basically can IO read until std IO buff reader new. Nice. So let's actually use that. So let's do std IO buff reader new. New takes a R, which is our reader, returns the buff reader, required by a bound introduced in this. What's that mean? What does that mean? Implicitly. Oh, okay. No, I want this problem. Should I no? What can I do with BR? Can I do okay, buff reader and then do IO read. Actually, until I can actually see that this is problem. Okay, read until gets a buff read implementation, a delimiter, and a buff. The delimiter is going to be this. Okay. Okay, let me just make this go away. Supply it. Can we do some cheating in here to make these errors? How is this working? I don't remember. I think it was like this. Derive debug, not debug actually, default. Okay. We don't have default implemented for. Okay, we cannot do this. Cannot do this. Let's actually search more. Read bytes into buffer. Socket read buff. What should I do? I actually thought that this part would be easier in Rust. I really thought that. Weird. Let's just do this. Let's do reader dot into std dot. So into std returns, is it result? Yes. So dot. We should probably have some dot read. Read, okay, read to end. Read to string. I don't want this. ReadBuff exact. I don't want this. Read. Okay, read to end. Read exact. ReadBuff. So one way of doing this, I actually don't know how. Actually, you know what? Let's do each bit of cheating. So we had this read until alloc something in here. Where was this? Read until delimiter alloc. So basically what it does, it says read until delimiter array list. Replaces the std array contents by reading std until delimiter is found. Right. So read 1 byte, just one. Yes. So it basically reads 1 byte each time. So we should do the same thing probably. So I should create a buffer, which is a 1U8. We should instantiate this. I really don't know. Like this. Okay. I don't know any Rust syntax. This is nice. Rust array. Actually, they had something in here. Let me just try to cheat from here. Probably they have something for that. Buff. Okay, it's okay. Buff. I can just do, first of all, it should be mute. The syntax is the, I think, default value, and the, so buff now is a level of type i32, which I don't want this to be, so I want this to be u8. One? Is that the syntax? Is it the syntax? Yes. Okay. So I want a buffer with a length of 1. So we do reader dot read buff read u8. Actually, this is maybe nice. Maybe this we should actually do this. Reader read u8. We don't need this, so we basically read a byte. If p equals \r \n, we create a buffer which is which should be a vector, std collections work. Okay. Std, where is this vector? Std vec new. If the buffer, if the byte that we read is a new line, we basically reach the end of this. So we should also do this in a loop. There are more sophisticated loops in Rust, but we don't need none of those. So let's do this. What it's saying now, it says I cannot compare this to char. Can I do char dot from b? Can you do this? Okay, it's probably yes. I should do this. For read. Okay, but should I do a wait? I don't think so. I don't know. Okay. So what this returns? Written dot wait read u8 dot wait. Okay, this is exactly what I was doing. Couldn't convert. What do you say? Await is only about loud inside async functions or blocks. Okay, this is okay because this is actually the coloring problem. So public async function. So first, then we need, so what's this error? What's B? What is B? Okay, so it says that I cannot convert the error into a string. Oh, okay, it's okay, because it's okay because it's trying to return error if it happened in here, and we already said that our errors are strings, so we cannot convert these. So we should see what is our error type. It's IO result, so we should use these. So basically our result is IO result of request. So this should work now, right? So now the U8 and char are not the same. So what we should do is probably U8 be into cool. So into basically is a really smart thing in Rust. So basically it looks at what this placeholder for a value is. So for example, in here the placeholder in the left hand side of this operation should be a char. So it tries to convert B into a char, and if it's implemented for type B, which is a U8, it can do it. So it says type oh, okay, so we should do ReadBuff something. Yes, so I should say is a wake of U8. Type annotations needed cannot convert type for type parameter T. So can I convert you to a U8? Remove this generics. Okay, I really don't know. Okay, so let's search for this as well. I don't know. Okay, so Rust compare U8 and char. This actually you can use as. Okay, as char. Okay, better. So there's also this as keyword that I think basically calls the as okay, I'm wrong. I don't know what as keyword do. Actually, let's find out that. So Rust as keyword, as what it does is cast between types of words. So how it do this type casting. Okay, as can be seen into the primitive. The primitive for from and into as only works with primitives, where from and into works with types like. Okay, I actually didn't like this part because I thought that we should be able to do this. Can we do from? Okay, so let's move on from this. This buffer should be mutable, of course. Cannot borrow reader as mutable because it's not. This should be also mutable. So yes, we can remove this parens. This should be mute. I know this should be mute. So what we say is, if B is so for each loop, I'm gonna read a byte, and I'm gonna append it. I'm gonna append this. Okay. Buffer append rec of u8 push dot push. Yes. Then if it's what we can do to make this, okay, you know what, I'm gonna say lines. I'm gonna do this in the most readable way but least performance optimized. So it's also should be a vec of u8s. And it can be vec std vec new. Okay, so if it is for this lines dot push buffer, we should clone this, of course, and buffer dot, how we can remove everything, empty. Okay, why my LSP is not working as it should? Std vec. There is this Rust extension, I don't know how to use it too. So can I what is clear? Clear the vector, removing all lies. This is what I want. Okay, where is my okay, so I should do clear, right, and this can be not mute. Okay, so basically for it, after this loop, can I do this buffer dot into string? Can I make a buffer into string? Vector passed into string. Vector of bytes to string from UTF-8 buff. We can use this. I prefer this, so we make this buffer of strings, and we use string from UTF-8 lossy, and it's going to be buffer dot. Try using a conversion method. Is that a thing? Buffer dot to string. Okay. Yes, we should do that. A string dot from UTF-8. So from UTF-8 converts a vector of bytes into string, and this function converts between them too. Not all byte slices are valid. Okay. So what's the difference between this and the lossy version? So the lossy version, invalid characters. Okay, this is what I want, probably. Actually, no. I just want this. This is a buffer, and this can probably fail, so we do this. We cannot convert this. Okay. Okay, this is actually a problem, because how I can have a generic error type? I mean, this function should have a generic error type. I don't know, but it's actually 1 hour and it's a bit late in here, so I'm gonna call it off. We're going to continue with this. I think even in this video we can see some things, see some points. So as you can see, Rust is really picky, really picky with its static analysis. So with the ownership of the value, mutations, and these things, and also the error handling is a bit actually not cool, because I think probably this is my lack of knowledge. Probably there is a way to compose multiple error types, but for now I don't know. So yeah, that is pretty much it. If you like this content, subscribe and follow, and also comment me if there is any problem or if the code can be better. Also, we're going to continue with this until we reach the same amount of features as the Zig implementation. So just for now, thank you and goodbye.